On LR3-1, we'll identify the hypothesis and conclusion of statements. We'll write conditionals, converses, inverses, contrapositives, and biconditional statements, as well as draw Venn diagrams and identify counterexamples. So we're going to use this statement as kind of our bouncing off point for all of these examples and definitions. So we're going to work with every creature who drinks water will die. Very dramatic, very over the top, but technically true. Technically, every single creature that drinks water will eventually die. My conditional statement breaks that apart, okay? And I'm going to have the first part is if something, and then I have the hypothesis, then followed by the conclusion. So if I go back to our example, every creature who drinks water will die, as a conditional, I could write that as if a creature drinks water, then it will die. Notice a creature drinks water is my hypothesis. It will die is my conclusion. My counterexample will prove any statement is false, and I only need one. So if I find a creature that drinks water but never ever dies, it proves the entire thing is false. Even though I have hundreds of thousands of other creatures that did drink water and still died, I just need one to prove it's not true. My converse flips my hypothesis and conclusion. The if and the then stay where they're at, but everything after and before the comma switches with everything after the then. So I would write, if a creature will die, then it drinks water. And sometimes I have to play with the English just so that it makes sense in English. Whether I'm changing a tense or whether I'm changing a few words, but I'm switching my hypothesis and conclusion. The inverse just makes it negative. So if I have if A, then B, my inverse is if not A, then not B. So going back to my example, I'm keeping my hypothesis and conclusion where it's at, but I'm making them negative. So if a creature doesn't drink water, then it will not die. And notice just because my conditional was true doesn't mean that my converse or inverses are true. Okay, so if a creature dies, then it will drink water, not necessarily true, right? I could have a creature that never drinks water because they're born and then they can never find water and they die of dehydration. They never drink water, but they still died. Likewise, if a creature doesn't drink water, they still very likely will die. Okay, so just because my conditional is true doesn't mean converse and inverse are true. My contrapositive kind of takes that inverse and that converse and smushes it together. So I'm going to negate and swap them. So if I have if A, then B, that becomes if not B, then not A. So if a creature will not die, then it does not drink water. When both my conditional and converse are true, I get to write it as a biconditional. And I take my statement if A, then B, and it becomes A if and only if B. Or I can write it as B if and only if A. Does not matter. So I could write a creature drinks water if and only if it will die, or a creature will die if and only if it drinks water. Venn diagrams were invented by John Venn, who was a famous mathematician, and he organized logical sets using circles. Okay? And you're probably used to seeing ones that look like this in language arts or social studies. But you could also have a set completely within a set, or you could have two sets that don't overlap at all. They have nothing in common. So we're going to practice this a little bit. We're going to work with the statement, if you finish your dinner, then you can have dessert. Your hypothesis is you finish dinner. Conclusion, you can have dessert. And your converse becomes, if you can have dessert, then you finish your dinner, right? You're flipping the ideas. You can have dessert, you finish dinner. The inverse keeps those ideas where they're at, but makes them negative. So if you don't finish your dinner, then you can't have dessert. And your contrapositive does both. So if you can't have dessert, then you didn't finish your dinner. You only need one counterexample to prove something is false. So in this case, maybe your grandma is babysitting and she always lets you have a cookie right before bed, even though she shouldn't. Great. My Venn diagram might look something like this. These are all the times I finished dinner, and there's a handful of times in there that I got dessert. Not every time that I had dinner did I get dessert, and there's a handful of times that I got dessert without finishing my dinner, but most of the times I got dessert, I finished my dinner.